What's up? What's up? It's your man, Jimmy Chan. All right, so here we're going to talk about graphing rational functions. And here are the steps as we go. So let's go ahead and do an example as I go through these steps so that I kind of can put the steps into action here so you guys can see what it means. So step one is the factor top and bottom. Okay, so number one, factor top and bottom. Great. So the top is a difference of two squares. So I got x minus 2, x plus 2, and put that all over x. Done. Step 2, find the domain. Okay, step 2, domain. Now let's change that to a different color here. Let's say red. I like the red because to find the domain, right, because it's a rational function, it really is that the bottom cannot equal to 0. So in this case, x cannot equal to 0. So that's enough. That is the domain. I can use everything except x cannot equal to 0, which means that if I was to write this in interval notation, that would be a negative infinity to 0, not touching 0, union with 0 to infinity. Okay, that's my domain. I typically like to find my vertical asymptote here because since the x doesn't cancel out with anything, then I have a vertical asymptote at x equals 0. So there's my vertical asymptote. This is typically where I like to find it. Once I find the domain, I got it. Okay, so it's based off the restriction anyways. Number 3, put in lowest terms. It's done already. Step 4 is to find the intercepts. Okay, so 4, find the intercepts. Well, the intercepts would be, the x-intercept is when y is equal to 0. And on a fraction, right, on a fraction, the fraction is equal to 0 only when the top is equal to 0. Okay, so is when the top is equal to 0. So for the x-intercept, I know that the y is equal to 0. So that means this fraction needs to equal to 0. So all I got to do is say 0 is equal to the x squared minus 4, right? If the top is equal to 0, 0 divided by anything is just going to be 0. So in this case, I already factored this, right? This was x minus 2 and x plus 2. So I know that I have my x-intercept at 2, 0. And negative 2, 0. There's that. All right, how about my y-intercept? Well, that's when x is equal to 0. So if I was to plug that in, I got 0 minus 2, 0 plus 2, all over 0. Oh, that's no good, right? Negative 4 divided by 0 is undefined. Well, here's the thing. I already know that x cannot equal to 0, right? Based on my step 2. So that therefore there is no y-intercept. All right, so I know that. Great. All right, what's next? What is step 5? Step 5 is to find my other asymptotes. All right, so I already found my vertical one. Let me find my horizontal one. So step 5. All right, so horizontal asymptote. I am comparing the largest power on top with the largest power on the bottom. Since 2 is greater than 1, right? The power on top is greater than the power on the bottom. I have no horizontal asymptote. Okay, that was quick enough. And with step 5, I need to find my oblique asymptote. So it's 2, so I can say 2 minus 1 is equal to 0. It's equal to 1. So that means the power on top is only 1 larger than the power on the bottom. So that means I would have to do long division. x squared minus 4 divided by x. How many times is x going to x squared? X times, so I have x squared minus, well, just x squared. So that's going to flip the sign and add. I'm going to have 0 minus 4, and then that's it, right? So really my remainder is negative 4 there. So I'm going to have a oblique asymptote at y equals x. Okay, now again, this would be based on this x, not this x. Okay, all right, so let me also box that up. Excellent. All right, and step 6 says, does it cross my horizontal or my oblique asymptote? Well, since I have oblique asymptote, so that's what I need to figure out. Does it cross my oblique? Now, since this is a y value, this is a y value, right? Let's go ahead and set those two equal to each other. So the top y value said x squared minus 4 all over x must equal to this x. I can cross multiply here. So I have x squared minus 4 is equal to x squared. When I subtract the x squared, I get negative 4 is equal to 0, which doesn't make any sense. So this is what we call a false statement. So that means it is not possible for this to occur, okay? So with that being said, I'm trying to find a way of making this fit on that page, but it doesn't look like it's going to do. It's okay. I'm just gonna go boom and put this down here. All right, so vertical asymptote at x equals 0. Hey, get back here. Okay, so can't touch that. I have an X-intercept at 2 and negative 2. Okie dokie. And then no y-intercept, clearly, because it can't cross the vertical asymptote. No horizontal asymptote. And we have an oblique asymptote of y equals x. And that would be a y-intercept of 0 and a slope of 1. So it should look something like that. Okay. And then it's not gonna cross the horizontal, the oblique asymptote. Okay. So if I have a point here that cannot cross the vertical asymptote, could cross the oblique asymptote, but it has already told me it's not going to cross it. And since the oblique asymptote is talking to me about the end behavior, meaning this graph is going to eventually get closer and closer to this line. Eventually going to get closer and closer to this line. So would it be truthful to say that this is probably going to show something like this? Or better yet, something like, oh gosh. Right? Something like that. Ooh, let's do this. Yeah. No, get out of there. Let's delete this. Let's draw something better. There we go. Oh, hey. Get back here. That's not. And let's say delete it, then it's no good. Okay? So again, this graph has to go through this point. It's got to get close to this at the end and get close to this. Same thing on this side, right? It has to cross this point. It cannot cross the vertical asymptote, so it's got to come this way and get closer. And it's not going to cross this, so it's got to get closer as well. So it's going to probably look something like this. Okay. So I'm going to guess that the graph is going to look something like that. All right. Next example. Analyze this graph. All right, let's take a look. So what was step 1 again? Factor. Okay, if I was a factor, I see r of x is equal to, on top I have a GCF of 2x, leaving me with x minus 1. The bottom I have x plus 3 and x minus 2. Okay, so it's factored. So now step 2, domain. Domain is that the x plus 3 and the x minus 2 cannot equal to 0. So I just want to remind you, I'm pausing here because I want to show you that this is, the denominator cannot equal to 0. Okay? And this is already in lowest terms, right? So I'm going to just throw step 4 in here just for poops and laughs, all right? Let me throw 4 in here because I might have to move it. To find the X-intercept, I know that y is equal to 0, right? So look at this. This is going to be 2x times x minus 1 is going to equal to 0. So look at the difference here, guys. This one here, I took the denominator and say cannot equal to 0. This one, I took the numerator and set it equal to 0. Okay? So numerator, denominator, numerator, denominator, numerator, denominator. Okay? Essentially, I'm saying both of them equal to 0 at some point, right? So this is saying that x cannot be negative 3 and x cannot be 2. That is my domain. So if I was to write this in a domain form or in an interval form, it would be negative infinity goes to negative 3, not touching negative 3, negative 3 to 2, and then 2 to infinity. Better yet, since nothing cancels here, right? Nothing cancels, nothing reduces, nothing goes away. I have a vertical asymptote at x equals negative 3 and x equals to 2. And that's the reason why they're vertical asymptote, is because x cannot be those numbers. All right? Step 3 is the lowest term. Step 4, I have to find out what makes the y equal to 0. That is if the numerator is equal to 0. So what does that tell me? That tells me that x is equal to 0 and x is equal to 1. So my X-intercept is at 0, 0, and 1, 0. Okay, there we go. All right, step 5, asymptotes. Okay, I forget what colors I use. All right, horizontal asymptote. So step 5, horizontal asymptote. I have to compare the largest power on top, which is 2x squared over x squared, right? Those are the two largest power terms. Great. So since 2 is equal to 2, that means my horizontal asymptote is going to be located at y equals the ratio of 2 over 1, which 2 divided by 1 is just 2. There is no oblique asymptote since 2 is equal to 2, right? So if it was 3 on top, power of 3 on top and power of 2 on the bottom, that's the only time that it would have an oblique asymptote. But since they are equal, there's none. So the next question is, does the graph intersect the horizontal asymptote? So the only way to find out is that, look, this is y equals, this is y equals. So the only way we find out is we say, okay, when is 2x squared minus 2x over x squared plus x minus 6 equal to 2, right? Because the horizontal asymptote is y equals 2. Okay, so 1 is equal to 2. So again, here I can cross multiply. And the only reason I can is because this is a single fraction, this is a single fraction. So I'm going to have a 2x squared minus 2x is equal to 2 times x squared plus 6x minus 6. Oopsie. I'm adding things in there. Plus x minus 6. Okay, so what do I have here? Let's take a look. So I get 2x squared minus 2x is equal to 2x squared plus 2x minus 12. The 2x squared goes away. So I'm going to move the 2x over to the other side. So I get a negative 4x is equal to negative 12. So x is going to give me a 3. So yes, the graph crosses the horizontal asymptote at 3, 2. Okay? Now, again, the horizontal asymptote is y is equal to 2, so that's why I put the y value as 2, and here I solve for x, so x value is 3. Okay? All right, so let's go ahead and throw a graph in here. Boom, add, there I go, boom, done. All right, so let's take a look. We have a vertical asymptote at negative 3 here. Awesome. Let's see here, let's make it that, and then let's duplicate that and put it into at 2. Boom, done. Okay. There we go. I have X-Intercepts at 0 and 1, 0. 0, 0, and 1, 0. I have a horizontal asymptote at 2. There we go. No oblique, and it's going to cross at 3, 2. Okay. So here's another great thing to think about. Okay. Remember when we were talking about odd and even power, right? And all that type of stuff there, right? So here's the thing. You know how when we're factoring this is to the first power, this is to the first power, right? First power, first power, first power, first power, right? You see all those first powers. Those first powers actually matter, right? So if you remember, actually, I should probably do it this way too. I should probably put these two powers here in blue, because what we did in blue is what? My X-intercept, which is also my zeros, right? So these power matter because it coordinates with my zeros, my X-intercepts, right? So if they're odd, that means when it crosses at these 2 points, it's going to go right through the X-intercepts, right? And these two are based on my vertical asymptote. So what does it talk about there? So, let's talk about that part, right? Because that's going to be a big deal there. So let's go ahead and do that. All right. So here, so I know that this has to go through either this way or this way, right? I don't know which way. Now, what about the vertical asymptote, about odd and even? Now, if it was even, actually I should probably write that in red, then it's probably going to do this, right? Where they both verge in the same way, okay? No matter if it's on the bottom or on the top, okay? We're not sure which one yet, but that would be even. Now, what if it was odd? If it was odd, then if this was going this way on top, then it would go this way on the bottom, right? Where they're in opposite directions. Either that way, or it will go, this way. Okay? But again, opposite directions. So that's the big part that you have to remember. Okay? So that is the piece that I want you to remember as we go. So since these ones here on the bottom are odd because they're both to the first degree, that means both of them are going to be opposite directions. And on top, they're all both to the first degree. That means it's going to go through. Okay? So as we look at this, I know that this graph has to either do this because it has to go through, or it's got to do this because it has to go through. All right? Now, remember that it's only crossing here. It's not crossing the X anywhere else. Okay? So, and it cannot cross the Y, the vertical asymptote. Okay? So you guys got to remember all those little tiny rules. Okay? All right, so let's see here. I want to make sure that I got everything else right. I'm pretty sure it's going to go up and right back down. Let me see. Because it's got to cross here, so is it going to go this way? Or is it going to go this way? And if it goes this way, that means this has to come up this way. And if it goes this way, that means it's got to go that way. Which means this got to go that way. Another good thing to kind of think about when you are stuck is to kind of throw in a point just to say, let's see what happens, right? So right now I'm truly not really sure if it goes this way or it goes this way. Because once I can figure out which way it goes, then the rest is pretty easy because I know that it's odd here, right? So if it goes this way, I know this is going to have to come up this way, and then that means this has to go that way, right? So if that is the case, if it is really around this point that matters, let's find out what happens here. So this is what, 1, 2, 3. So let's go ahead and find out what happens at f of, let's pick a pink here, 3. Okay? So let's see what happens at f of 3. So I'm going to use a factored form because that's probably easiest. So I'm going to have 2 times 3, and then 3 minus 1 over 3 plus 3 and 3 minus 2. Okay, so let's see here. What is that going to give me? So f of 3 is going to equal to, the top is what? 6 times 2, right? Because right here is 2 times 3 is 6. 3 minus 1 is 2, so 6 times 2 is 12. Down here is 3 plus 3 is 6. 1, so that's going to be 6. So that's going to be 2. So, oh shoot, we already knew that. I just plotted this point incorrectly. This is supposed to be 3, 2, which is this point here. So I can't use 3. Well, let's use 4. Why not? Let's use 4. Let's see what happens with 4. Because the backside also helps. Okay, let's take a look. 4 minus 1 is 3. 3 times 4 is 12. So I'm going to have, what, 24, right? And then the bottom is going to give me, this is 7 and 2. That's what, 14? All right, 7, 2, 14. So what is 24 divided by 14? That's about 1.7. Okay, so at 4 is about a 1.7. So somewhere here. Okay, so that's the dead giveaway right now. Okay, so I know that this is going to have to go through this point and up. So there we go. So that's cake. That's going to help me a great deal. So I'm trying to pick a color here. Green. I guess I'm left with poop brown here. So that means I'm going to have something like this, right? And since this one is odd, that means this is going to have to come up this way and somehow loop to do something like this. Okay. And then this is going to have to kind of go this way. Okay. Now, again, the reason why I can't let this cross the horizontal asymptote, even though if you're allowed to, is because it doesn't say that when I was looking for it, it doesn't say it would cross anywhere else. Right? I'm not going to let this cross the x-axis because when I looked for x-intercepts, I didn't find any other x-intercepts besides these two. Okay? So that's why I can't let it cross over here past the x-axis or another x-intercept. Right? I can only cross the horizontal asymptote here because I found that. I didn't find any other one. I know I can never cross the vertical asymptote. And since this vertical asymptote is odd, I know that they're got to be opposite, pointing in opposite directions. And this is odd, so it's pointing in opposite directions. Okay. Well, I hope this helps. If there's any, oh, wait a minute. We're not done. All right. I hope that helps on that part. Okay. So it says make up a rational function that might have the graph shown in the figure. Okay. So might. So what are some key things that we need to look at? Some of the key things is this. I can see that I have vertical asymptotes at x equals -4 and at x equals 2. Okay? So if that's the case, then I can already start my function. Because I know my denominator has to be an x plus 4 and an x minus 2. Not just that, guys. Not just that. Look at this. Look at this. Look at this. See this right here? Since this is pointing in the same direction, I know that at x equals 2, it's going to be even because they're pointing in the same direction. So that means, and the smallest even I know is 2, so this has to be squared. And over here, look at these arrows. These are pointing in opposite directions. So since these are pointing opposite direction, I know that at x equals -4, it's going to be odd. And the smallest odd I know is to the first power. So there I go, to the first power. Okay? Great. What else do I know? I know the X-Intercepts, right? It is at x equals -1 and x equals 3, right? And at x equals -1, it's going to be even multiplicity. And at 3, it's going to be odd because it goes through it. And at -1, it bounces right off of it. Okay. Guess what that's going to help me with? That's going to help me get the top of this rational equation. So the top is going to be x plus 1 squared and x minus 3. So really just with those two, I'm going to get something that might have all of this that I need. Okay. Did I use the horizontal asymptote yet? Yes. Well, no, that's definitely the answer. No, it has not. I haven't used the y-intercept, right? So I'm not sure if the y-intercept is -1 or not. But all of those are going to come into play to refine this equation. But right now, the quick and dirty part of this is just to get this right. So let me see here. This was even, and this was odd. Okay? So those two will get me to a startup equation to start with that is somewhat close to this graph. All right? I hope that helps. If there's any questions, please let me know. See ya. Bye.